So we're beginning chapter 4 today. I already gave you a handout. Right now I just want you to pay attention, right? We're going to just talk a little bit. So we're going to be on section 4.1, graphing standard form quadratic functions. So we need to know what a quadratic function is. A quadratic function is anything with the x squared in it, right? So, but before we even begin, the word form, what does that mean? Where have we seen the word form before? Slope-intercept. We've dealt with slope-intercept form. We've also dealt with point-slope form, right? Now, so what does the word form actually mean? The way it looks, all right? The way it looks, the way it's organized, right? So if you have your equation organized, like for example, this one right here, if I say 3x minus 4y equals 8, that's definitely not in slope-intercept form, right? So if you wanted to graph this using slope-intercept form, you could rearrange it. You could move things around, get y by itself. That way it becomes easy to graph, right? So when you have it in a certain form, when it's organized, you could find things, important things, especially depending on what you're trying to do. It's kind of like if you have your room a giant mess, right? You just throw all your clothes on the floor, and then you're looking for a certain shirt. You're not going to be able to find it easily. But if you have everything organized in a certain form, you'll be able to find that shirt easily. So the word form just means how the equation is organized, how it looks, okay? So let's move this out of the way. See, when it's organized, if I ask you to find the Y-intercept, what's the Y-intercept right there? 4. That's 4, right? Nice and easy. Why? Because we know that it's in y equals mx plus b, and we know that the b value is the Y-intercept. Let me throw in a review question out there from Algebra 1. What if I told you to find the x-intercept? Okay, the form doesn't really help us here, right? But do you guys remember how to find the x-intercept? From Algebra 1, how do you do it? Anybody? To find the x-intercept, you... Anybody? Set... That's right. To find the x-intercept, we set y equal to 0 and solve. To find the y-intercept, you set x equal to 0 and solve, right? So if I did ask you to find the x-intercept, you would have to set the y equal to 0 and solve. So just for funsies here, the y would be 0. You'd have 1/2 x plus 4. Then you'd have to subtract 4 on both sides. You'd have a negative 4 equals 1/2 x. You'd have to multiply both sides by 2 to cancel it. And you get negative 8 equals x. So the x-intercept is the location on the x-axis at negative 8. That's where it would cross. The line would cross the x-axis at negative 8. Anyway, that's just from Algebra 1. Why am I bringing that up right now? Because it will pop up on today's lesson. But let me erase this. So what other forms have we dealt with? We've also dealt recently, when we graphed parabolas, with vertex form, right? And vertex form is great when you want to find the vertex, HK. Today we're learning about standard form. And what's standard form? It's ax squared plus bx plus c, or a, b, and c are just numbers, okay? But it is a quadratic, right? Which means x squared. And x squares produce parabolas. So let's move on to our worksheet here, our handout, which has notes and practice. So as you could see, these are very familiar or similar notes to the ones we did back when we did vertex form. I even started this parabola, this parent graph parabola, y equals x squared. I graphed it for you using an xy table because we've already done this in the past. We know that the x's are your input, the y's are your output. But the only difference now is instead of vertex form equations, we're going to be dealing with standard form quadratic trinomial equations. Just remember this, guys. A, B, and C are just numbers, okay? A, B, and C are just numbers. Now, it is true that we've dealt with the A value before. The A value is very important. It tells us if it opens up, if it opens down, if it's wide, if it's narrow, or if you want to use the correct vocab in math, if it's vertically stretched or compressed, right? But anyway, the A, B, and C are just numbers. We already know parabolas are just U-shaped curves, and we've already dealt with this parent graph parabola. And we already did an input-output table in the past. When you plug in 0, 0 squared is 0. So when you plug in 0, you get out of 0. When you plug in 1, 1 squared is 1. So when you plug in a 1, you get out of 1. When you plug in 2, 2 squared is 4. When you plug in a 2, you get out of 4. We already know this stuff. What if my A value would have been a 3 right there? What would happen? Like instead of when I plug in a 1, I'd get 1 squared times 3. So that 1 would become a 3, right? If I plugged in a 2, 2 squared is 4. 4 times 3, that 4 would become a 12, right? So you could still use this pattern of 1, 1, 2, 4, 3, 9, but you have to modify the outputs according to your new A value. And this is stuff that we should already know. We did this in the first quarter. Everybody cool with that? It's all a review right now so far. The vertex, we already know that the vertex is the highest or lowest point. We know it's a coordinate. It's the most important point when graphing a parabola. Back when we did vertex form, it was really easy to find the vertex. It was just simply h and k. Think opposite on h, take k for what it is. Okay? But now, since we're dealing with standard form quadratic functions, we're going to have to memorize this vertex formula. X equals negative b over 2a. Okay, we need to memorize that. X equals negative b over 2a. And this is for a standard form quadratic function. Again, standard form is this guy up here. If it looks like that, I mean, if I told you what's a vertex, well, there is no h and k here, so you're kind of stuck. You can't see the vertex. So what are you going to do? You're going to use the formula x equals negative b, whatever this number is, put a negative in front of it, divided by 2 times a, whatever this number is. So this is the vertex formula. This is what we need to memorize. X equals negative b over 2a. That's only good, or that is great for standard form functions. Now, if we move up here, it says, remember, the vertex is actually a coordinate. This formula will only give you the x value. You still need to plug it in to find the y value. Okay? We already know about axis of symmetry. It's that beautiful green dotted line that I always use on my videos that provides a reflection from one side to the other. And we already know that the axis of symmetry equation is x equals the x value of your vertex. But since we know that this formula gives us the x value of our vertex, then technically the axis of symmetry equation is also x equals negative b over 2a. Okay, so I do give you steps to graphing standard form quadratics using an xy table. You could still use the pattern 1, 1, 2, 4, 3, 9, but you'd have to modify it accordingly with your new a value. But right now I want to practice using an xy table. So step 1 is to find the vertex. Just like before, the first thing you should do is find the vertex. So everybody go to this example. Let's put a V for vertex, put the coordinate. And what we need to do is write down the formula, x equals negative b over 2 times a. And whenever you use any formula, I recommend using parentheses. So a negative parenthesis over 2 times parenthesis. And of course, the b value is right here at 6. The a value is right here. It happens to be negative 3. So what do we have here? We have a negative 6 divided by a negative 6. So what's my vertex x value? My vertex x value equals 1. So everybody put a 1 for your vertex x value. So this is a heck of a lot more work than what we did before with vertex form, because vertex form, you just look at h and k, think opposite on h, take k for what it is. Right here, we actually have to memorize the formula, apply it correctly, get an answer, and this is barely our x value of the vertex. Anytime you have the x value and you want the y value on any equation, what do? Plug it in. So we're going to go back to this entire equation, and I'm going to rewrite it, but instead of x's, I'm going to put parentheses so I could put my x value of 1 right into those x positions, right? So let me rewrite it with parentheses instead of x's. So there it is. And let's plug in our x value of 1 right in there. And now let's do some math. Of course, PEMDAS is always what the order you need to do math. So parentheses first, but there's nothing to do inside the parentheses. We actually just plugged in a 1. Move on to e exponents. So 1 squared is 1. So what we really have here is negative 3 times 1. That's just negative 3. And how about 6 times 1? That's just 6. Bring down the plus 5. You end up with negative 3 plus 6 plus 5. That's really a 3 plus 5, which is really 8. Yes? What did we just find right here? The y value of our vertex. Y equals 8. So let's go back up here to the vertex coordinate. And that is barely step 1. Okay, Okay, that's barely step 1, finding the vertex. That's the only new hard part that we're doing. Everything else is the same. Okay, everything else is the same. So the only new challenging part today is memorizing this formula, x equals negative b over 2a, knowing where to get your b and your a from. It's from your standard form quadratic trinomial equation. And then once you have that vertex, everything else is the same. So let's graph the coordinate 1, 8. Go 1 on the x and 8 on the y. It'll be way up here. So just like before, what would be the next thing to do after graphing this vertex? Axis of symmetry. So I, on my videos, always use a green dotted line for the axis of symmetry. And of course, we might as well state the axis of symmetry equation. Before, we said it's simply x equals the x value of your vertex. It's the same thing here. What's the x value of our vertex? 1. So the equation x equals 1 will produce this green dotted line right here. It's a vertical line crossing the x-axis at 1. This is a great line because it provides reflection from one side to the other. So at this point, you could use the pattern 1, 1, 2, 4, 3, 9, but you'd have to modify your outputs according to your new a value of 3. Now some people are thinking, well, why not negative 3? Negative just says that it's opening down. That's all you have to worry about with the negative. It opens down, but you'd have to modify the outputs by 3, and then you could use that as your new pattern from the vertex. However, let's not do that right now. If you want to, you could, but let's go back, or let's go to this other side, and instead of using the pattern being modified, let me write down an input-output table, an XY table. Everybody do that, please. And let's go back up to the notes up here. On the notes, it says step 3. We already did step 2, draw our axis of symmetry. Step 3, plug in 2 numbers on the same side of the axis of symmetry, and then map them over to the other side. So here's my axis of symmetry. Give me 2 values that are on the same side of the axis of symmetry. 2 x values. What do you say? Any numbers. Go for it. 2 and 3? 2 and 5? Sure. Okay, I would go with 2 and 3 because it's easy to plug in 2, it's easy to plug in 3. But it's even easier to plug in what?
1.
What's the easiest number to plug in? 0. Okay, so check this out. So here's my axis of symmetry. My x value of 0 is on this side. I want to plug in 0, and let me show you how easy it is to plug in 0. You don't actually do any math. I mean, well, we will the first time. How about this? Plug in 0 right here for x, 0 right here for y. So you have 0 here, 0 there. 0 squared is 0. Negative 3 times 0 is 0. 6 times 0 is 0. 0 plus 0 is 0. And 0 plus 5 is 5. So let's understand this, guys. On a standard form quadratic trinomial, plugging in 0 is the easiest. Why is that? Because it's always going to be the c value. The 0 eliminate everything except for the c value. So this is really easy to do, right? It's even easier than modifying the pattern. Now let's just pick one more value that's on the same side, which happens to be the left side of the axis of symmetry. So which other number would you plug in? If you plugged in 1, guess what you would get out? You'd get out what you did over here on the vertex. Plug in 1, you already plugged in a 1, you got an 8. So if you plug in a 2, you're going to get out a 5. Now, how do I know that? Because I already know that my coordinate 0, 5, 0, 1, 2, 3, 4, 5 is right here. And I know I'd map it over to the other side, so if I plugged in a 2, I'd get out a 5 anyway. So that's why the instructions say plug in 2 values that are on the same side of the axis of symmetry. So if we plugged in a 0, which is clearly on the left side of the axis of symmetry, and we got out a 5, let's plug in another number that's on the left side. What's another number on the left side? Negative 1. So let's plug in a negative 1, and this is probably the only one that we actually have to show work on. Okay, so let me do this. I'm going to go up here to this blank area up here, and I'm going to rewrite this guy with parentheses instead of x's. That way I could take this negative 1 and plug it right into those x's. So again, the idea is to plug in 2 values that are on the same side of the axis of symmetry, and 0 is always super easy to plug in, right? So let's plug in the negative 1 into those parentheses, into the x spots. Let's do some math. Always exponents first. Negative 1 squared, that becomes positive 1. Positive 1 times negative 3, that's really a negative 3. 6 times negative 1, that's really a negative 6. Plus 5 is at the very end. Negative 3 minus 6, that's negative 9. Negative 9 plus 5 is negative 4. So when I do input the -1 into my x positions, I get an output of -4. So -1, -4 is a coordinate. That's the only real math that I'm doing, right? So let's go to the coordinate -1, -4. So let's go -1 and -1, 2, 3, 4. That would be right here. So all you have to do is map these coordinates over to the other side, right here and over here. As you can see, this parabola is kind of narrow, but we already knew that because the a value is further away from 0. It's opening down. It's kind of narrow because the 3 is further away from 0 than 1. So that's why it's narrower and it's opening down. We could have used the pattern. So let's go back to the pattern. Let's just show both ways. 1 from the vertex, 1 times 3 is 3. So 1 over 3 up. 2 from the vertex, 4 times 3 is 12. So 2 over 12 up. Actually, I'm saying up, but it's -a, so I should be down. So if I did go to the vertex and go 1 over 3 down, I would get to that blue dot. If I do go to the vertex and go 2 over 12 down, I'd get to this blue dot. So it's the same result, right? But on this section, I do want you to practice using an XY table, okay? I want you to practice picking 2 numbers. Always use 0. 0 is great because when you plug in 0, it's simply going to be your C value. So you don't do any math right there. Always use 0. And then just plug in one more number on the same side of wherever that 0 is at, either on the left side of the axis of symmetry or the right side of the axis of symmetry. This one's a little interesting because you could technically look at it in standard form or even in vertex form, okay? If I say standard form, what's my B value? Well, my A value is 1, but what's my B value? My B value is not there. Remember, it's BX, right? BX. So it doesn't have a B value. Your B value is 0. And your C value, of course, is -3, but you don't use a C value in your formula. So X equals -B over 2 times A, negative parenthesis over 2 times parenthesis. Now, this is how we get the X value of our vertex. Okay, so when I plug in the B value of 0 and the A value of 1, it's really easy because 0, doesn't matter if it's positive or negative, divided by any number. What's 0 divided by any number? 0. Still 0. Okay? So that's my vertex X value. How do I get my Y value? By simply plugging it in. Now when you plug in 0 into a standard form equation, it's going to be your C value, your answer. Right? 0 squared is 0. 0 minus 3 is -3. So the vertex is 0, -3. Let's go to the coordinate 0, -1, 2, 3 right here. Put a dot right there. You should draw your axis of symmetry, but I normally don't even draw the axis of symmetry whenever it's on the y-axis itself. And of course, we need some more points. So in this one, I would most definitely use your pattern 1, 1, 2, 4, 3, 9. Why would I use a pattern? Because the A value is 1. You don't even have to modify the pattern. But if they did ask you to find 2 other coordinates using an XY table, then of course you could plug in any 2 numbers that are on the same side of the axis of symmetry, like 1 and 2. So it's really easy. 1 squared is 1 minus 3. That would give me the output of -2. Plug in a 2 right in here. 2 squared is 4. 4 take away 3 is 1. So you could go to the coordinate 1 on the x, -2 on the y, and put a dot right here. You could go to the coordinate 2 on the x, 1 on the y, put a dot right here. And of course, you could map over those coordinates to the other side, and you have your perfect U-shaped curve, right? But I wouldn't have even done this. I would have actually focused in on the pattern 1, 1, 2, 4, 3, 9 because you don't even have to modify it. So you could go 1 over 1 up, 2 over 4 up, 3 over 9 up, right? So there's my dot, 3 over 9 up. Just map it over to the other side. Connect your dots and you have your perfect parabola. So we've already graphed parabolas in the past that were in vertex form. Everything's exactly the same. By the way, I've been skipping out on a lot of different things. For example, I should have asked on this first one, what's the domain and range? Let's go back and do that. So the domain are your x values. X equals what? All real numbers. Because it does go to the left and to the right forever. Okay, how about the range? The range are your y values. Does this go up and down forever? No, it actually reaches a maximum point, right? From left to right, it reaches a maximum point, maximum height, and then it comes back down. What's that maximum height? The y value of your vertex, 8. So what do we say? Y is less than or equal to that y value of the vertex, which is 8. What else could they ask us? They could ask us for the domain, the range. They could also ask us, ladies and gentlemen, for the y-intercept, y-int. And you could clearly see where it crosses the y-axis. Where does it cross the y-axis? 5. Now, it's even easier to think about that algebraically instead of visually, because right here you're counting 1, 2, you might mess up. Right here visually, to find the y-intercept, you set x equal to 0. So what's your answer going to be? The c value, the 5. Okay, so that's another thing they could ask you. The y-intercept is 5. They could also ask you for the axis of symmetry equation, x equals 1. So that's about it. How about this guy over here? What's the domain? X equals all real numbers. How about the range? Y is greater than or equal to -3, the y value of the vertex. Axis of symmetry would be x equals 0. It's a vertical line going through the x-axis at 0, which is actually the y-axis itself. And that's about it. So these are the notes. Guys, we're not doing anything new besides this, right? We used to have a nice, beautiful vertex form, and you could see h and k. Think opposite on h, take k for what it is. But now we're dealing with these guys, which are standard form, and you need the formula to be able to get the x value of the vertex. Then you plug it in to find the y value. And also, on this practice on the backside, I would like you to practice using an XY table and plugging in 2 numbers that are on the same side of the axis of symmetry. Okay? But of course, if it's super easy to use 1, 1, 2, 4, 3, 9, like right here, you might as well use 1, 1, 2, 4, 3, 9. Okay, let's practice on the back, guys.